Okay. All right, class. So you completed the paper folding task and you worked together to do your measurements. You measured angles and you measured segments. Now we're going to talk about what conclusions you have about those measurements. All right, we're going to start with the group in the back. Go ahead. I want you guys to give me 3 conclusions. All right? So go ahead, Eliana.
All 4 triangles are congruent.
All 4 triangles are congruent. Okay, Jake, how did Eliana find that?
Because all the sides in the triangles and the angles in the triangles are congruent.
So when you say all, I want facts. Can you give me some measurements, Jake?
Okay, in the there's 45, or no, all the base angles are 45 and the vertex angles are 90.
Okay, so when you say base angles, Jake, hold up your triangle and show everybody where the base angles are.
So the base angle, for example, this triangle is 45 and 45, and right here it's 90.
Very good. And Eliana, you agreed with him? You found the same? All right, 45 degrees. 45 degrees. And up here you're saying Jake is 90?
Yes. Wait, no.
Right here?
Yes.
Yes. Fabulous. Let's move on to this group. Go ahead, Olivia and Katie, what did you find?
We found that the midpoint is right here, so these 2 sides are equal and these 2 angles are equal.
So you're telling me this is a midpoint right here.
Mm-hmm.
Do you agree with that, Olivia?
Mm-hmm.
All right, so we have congruent segments. What do you have for measurements of those segments?
6 inches.
6 inches.
And we found that those 2 angles are equal to 45 degrees.
These angles are 45 degrees right here. Olivia, give me one more fact.
Since each of the triangles are isosceles triangles and both of those angles equal 45, then the top angle is 90. Is that equal to 1?
Right here.
Yeah.
Excellent work. Is everybody agreeing on what we're finding so far? Nice job. All right, let's go to Emma and Rohan.
I said all the triangles are right angles.
All of the triangles are right. Come on up and show me where the right angles are, because I don't have them all up there. I have 2. Thank you. Good work. Everyone agree? Nice work. And what do you think, Emma? What else can we add to this?
Well, I was gonna say that I see 13 triangles in total.
13 triangles. All right. Why don't you come up and show everybody where you see 13 triangles? We might have to add some things here, but it sounds good to me.
Okay, so there's this through the middle, and so that's 1, 2, 3, 4, then 5, 6, 7, 8. This whole thing is 9, 10, 11, which is the whole thing, and
Did you get the entire triangle?
yeah, I have it. 6.
Can anyone think of one she missed?
5. 6.
Yeah.
Yep.
Wait, yeah, that's
I think those are the last.
11, 12, and 13. Yeah.
Excellent. It's not what we were looking for, but that's great. I love that. Does everybody see what she's talking about? So we've got triangles inside triangles, which we have been seeing in our proofs. A lot of times it's tricky to see those triangles, so good job, Emma. Fabulous. Okay, and so we've got this group left to add to what we've already found. I'll continue. I'll write in red now so it stands out as far as our measurements. Go ahead.
So that line Emma drew,
Yeah?
that's the perpendicular bisector.
How smart is that? Perpendicular bisector. So you're saying this line comes down here and we have what?
90-degree angle.
90-degree angle there. And so that's the perpendicular piece. What makes it the bisector piece?
Because it cuts in half these 2 the vertex angles.
So you measured these angles, Jacqueline?
Mm-hmm.
What did you find?
They're both 45.
45 degrees. 45 degrees. How about the segments on the bottom? Does it bisect the segment on the bottom, Grace?
No. Yeah.
It does not. Well, tell me about your measurements. What did you find?
Well, I found that the four angles in the middle were all equal to 90.
Those angles right there are all equal to 90. Very nice. Okay, did anyone measure this segment? Kate,
They're each 3 inches, so the entire thing is 6 inches.
the entire thing is 6 inches. Do you see 6 inches any other place? I'm going to take some of these numbers out now so we can see a little bit better. Okay, so 6 inches. Do you see 6 inches any other place?
The bottom.
Yeah, and that goes back to our first fact when Eliana said we have congruent triangles all over the place, right? Because we've got congruent sides, 6, 6, 6, and so on. What is the entire length of the base, Jake?
12.
It's 12. So can we draw a conclusion about that? Compare those segments. How do they compare, Olivia?
Well, they.
Anybody? How does 6 compare to 12?
It's half.
It's half. So this segment right here, this segment comes from connecting the what? What do we call these points? The
Base.
So tell me this. When you measured this segment and this segment, what did you get, Jake?
Wait, no. 8.5, I think.
Okay, the whole thing was 8.5, and each of these segments?
4 and 1/4.
4 1/4. 4 1/4. Whole thing was 8.5. Okay. Did anybody measure this segment? What'd you get, Rohan?
4 1/4.
4 1/4. Take a look at what's happening. We measured this. We measured this. 6 was half of 12. What happened here? What happened here, Emma, when we measured the lengths?
The side of the smaller triangle was half of the.
Yes, that's it. So this is the theorem that we're going to talk about today. We're going to look at it a few different ways. We're going to look at it on the coordinate plane in a moment. When you connect the midpoints of two sides of a triangle, that's called the mid-segment. Can you write it on your triangles, please? And think about what Emma just told us. The mid-segment is equal to, one more time, Emma?
The length of the small. Wait, no.
So it's
Half of the whole
half the
thing.
length of the third side, correct? The mid-segment of a triangle is equal to half the length of the third side, the side that has been untouched. And we see that in every place. Okay, let's get that in our notebooks, everybody. The lesson you'll be observing is an example of students thinking critically as well as collaborating and communicating with one another. After participating in a paper folding activity with me where students started with a square and did some folds to make triangles and mid-segments, students were then working in pairs to measure all of the angles and all of the segments formed in the triangle. Once the measurements were recorded, the groups synthesized and analyzed their data to come up with some conjectures about the triangles. They then shared their conclusion with the rest of the class, some of them coming to the smartboard to do that, you'll see that, as well as coming up with some conjectures about what they found. With that information, students were then able to reason the mid-segment theorem, which is a really important theorem in geometry. They discovered that the mid-segment is equal to half the length of the third side of the triangle and also parallel to the third side. When students discover theorems like this on their own, rather than just simply copying them down, they retain that information, and that's what I hope to achieve by using specific techniques that are laid out in our strategic coherence plan.